Good morning students, welcome to this video. This video is in continuation to my previous video on Introduction to Trigonometry. Let's see what we all discussed in that previous video. We discussed the term T ratios, in short trigonometric ratios. We discussed the various relationships amongst all those 6 T ratios. They are 6 in number, like sine, cos, tan, cot, secant and cosec. 2 important properties like the reciprocal results and the quotient results. On top of that, what we discussed, if you remember, we discussed that if a single T ratio is given to you, how we are able to find the value of different other T ratios. That means 5 other T ratios. And again, if a single T ratio is given, how you are able to evaluate T expressions. And if a single T ratio is given, how we are going to verify trigonometric equations. That was in the previous video. Now, as for this video is concerned, this is T ratios of some specific angles. Now, the theta that we took in the previous video, that theta is an acute angle. It could take different values from 0 to 90. That means theta is in the first quadrant. Values taken by theta are from 0 to 90. But there are some specific angles which we come across in daily life. Like theta is 0, theta is 30, theta 45, 60 and 90. Now in this video, we'll try to evaluate the values of all 6 T ratios for these 5 angles. That is, theta is 0 degree, 30 degree, 45 degree, 60 and 90. So we will evaluate values of all 6 T ratios for all 5 of these T ratios, 0, 30, 45, 60 and 90. Then we will be applying these values to different sums asked in our textual exercise. We'll first find the value of 45. After that, I will take up 30 and 60, which is combined. And at the end, we'll take 0 and 90. So let's take the value of 30 and 60. Now, if theta is 45, let's take 45 first. My question is, find the value of all T ratios for theta. Let's take 45. Theta equal to 45 degrees. Then we'll take 30 and 60. 30 and 60 is combined, the common figure. Now, my theta is 45, so I will take a right angle triangle, ABC. If this has to be 45, as you know, this is already 90, then this is also 45 as per angle sum property. So this is also 45. That means this side has to be equal to this side. It's an isosceles right triangle. Let me take AB as A. So BC is also A. Now, in order to find the third side, we'll apply Pythagorean theorem. So by applying Pythagorean theorem, I will have AC square as AB square plus BC square. Now, AC square will be, this is A square, this is also A square. That sums up to 2A square. Now, AC will be the positive square root of 2A square, that is A square root 2. So my AC length is A square root 2. Now mind it, you have all 3 sides of a right angle triangle. We could find any T ratio as far the theta is concerned, and theta is 45. So let's try to list. My sine of 45 is, sine is perpendicular by hypotenuse, so that will be A upon A square root 2. So that is nothing but 1 upon square root 2. My cos of 45, cos is base upon hypotenuse, so it's B upon H. My base is A and hypotenuse is A square root 2. It's again 1 by square root 2. So here you could see sine 45 and cos 45 values are same. Let's take up tan. So tan of 45 degrees is perpendicular upon base. Perpendicular is A and base is A, so that is 1. Tan 45 is 1. Now with the help of these 3 T ratios, we could find the values of the remaining 3, which happen to be the reciprocals of these 3. That's quite easy. Means your cosec 45 will be root 2 upon 1. Your secant 45 will be root 2 upon 1. And your tan of 45 is again 1. That is quite easy for you. So that way, we have derived the value for all 6 T ratios for theta equal to 45 degrees. Now let's move on to theta equal to 30 as well as 60. There's a combined figure for theta is 30 and 60. You will be rubbing this. So find the value of t ratios for theta equal to 30 and 60. So we'll do it together. Now in this case what we do, we'll be taking an equilateral triangle. Let's take ABC, an equilateral triangle. ABC. That means if this is an equilateral triangle, all three sides are equal. Each angle is 60. So this angle is 60. And let me take BC as 2A. You could take A also. This is also 2A. On any length, they are all three lengths equal to A. So I have to derive T ratio. That means you need a right angle triangle. You don't have a right angle triangle, you have an equilateral triangle. We'll drop a perpendicular. Let me drop a perpendicular from A. This is AD. So we have a right angle triangle ADB. Now there's a common result as far as equilateral triangle is concerned. Perpendicular bisects the base. I hope you remember this, because if you observe ADB and ADC are equilateral triangles by RHS. ADB and ADC are both congruent triangles by RHS. So that means BD has to be equal to DC. BD plus DC is 2A. That means BD is A. Perpendicular bisects the base in an equilateral as well as in an isosceles triangle, because these two triangles are congruent by RHS. So let's work on this right angle triangle. This is ADB. ADB. My BD is A. This is already given to be 2A. This angle is 60. This is 90. What about this third side? For that we'll be using Pythagorean theorem. So we say AD square is equal to AB square minus BD square. This is the other way of expressing the Pythagorean theorem. Usually you say square on the hypotenuse is sum of the squares on the remaining two sides. So I said AD square will be AB square minus BD square. So AD square will be, AB is 2A, square of that. BD is A, square of that. So that is 4A square minus 1A square, that is 3A square. So what is then AD? It's the square root of 3A square. That is A square root of 3. So your AD length is A square root of 3. You have all three sides of a right angle triangle given. My dear friends, if you observe, this angle has to be 30 degrees, because as per angle sum property. So you have a right angle triangle in which one of the acute angles is 60 and one is 30. That's what I said in the beginning. 30 and 60 we will find in a single diagram. So now we'll enter this triangle and find sine for 30 as well as for 60. So let me write sine of 60. This is my 60. Sine 60, sine is P by H, perpendicular by hypotenuse. Perpendicular is A square root 3 upon 2A. So that is root 3 upon 2. Cos of 60 is base upon hypotenuse. What is base for 60? Don't forget, when this is angle, this has to be the base. That is A upon hypotenuse is 2A. That is 1 upon 2. So cos 60 is 1 upon 2. And what about tan? Tan of 60 will be perpendicular upon base. Perpendicular is A square root of 3 and base is A. That is square root of 3. So we have prepared sine, cos and tan for theta equal to 60. And for the remaining three T ratios, which happen to be reciprocal, you could easily prepare. Means your cosec 60 will be, if you observe, reciprocated, cosec 60 is 2 upon square root 3, and your secant 60 will be 2 upon 1, that is 2, and your tan of 60 is 1 upon root 3. This is nothing, root 3 upon 1, reciprocated 1 upon square root 3. So we have been able to find the T ratios for theta equal to 30, equal to 60, as well as 45. Now, we'll move on to theta equal to 0 and 90. Then we will tabulate all values. You have 6 T ratios and 5 angles. That means 5 into 6, you have 30 values to retain. But I will give a small table which you refer to during examination. Make that table and work on the sums related to that topic. So I will rub this and I will move on to theta equal to 0 and theta equal to 90. Now 0 and 90, why I took it in the end, this is a little bit abstract, because theta equal to 0, what does that mean? That means theta is 0, so the initial arm and terminal arm, they both coincide. And in that case, does a triangle exist and theta equal to 90? How theta can be 90? Because there's already a right angle in the right angle triangle. In a right angle triangle, you can have only one right angle. So you are taking that acute angle to 90. See, these are limiting cases. If theta approaches to 0, what happens to the right triangle? What happens to the hypotenuse? And if theta approaches to 90. So in that case, we'll make a diagram. Theta equal to 0 degrees. Find the values of t ratios, all t ratios, theta equal to 0. Now let's see what happens when theta is decreasing. It goes back, is the final arm comes back to the initial arm. Let's see using the diagrams. If this is my first diagram, this is my right angle triangle ABC. This is theta. Now you are saying theta approaches to 0. That means C has to come to B. So my second diagram will be like this, little bit smaller. This is A, this is B, this is C. So we have to decrease. The magnitude of this theta is to be decreased. That means C is coming down, C goes to B. My third figure will be something like this. C goes to B, this is A, this is theta. One more figure. C goes to B, this is theta. And lastly, you will have something like this. If you make it much smaller. Okay. Now what happens? See, when theta tends to 0, it's approaching 0. We're observing what happens. When theta approaches to 0, that means this difference between the initial arm and the terminal arm, this magnitude, it decreases. This is second figure, third figure, fourth figure, and so on. As theta decreases, it approaches to 0. We observe that C comes closer to B. So C approaches to B. C comes closer to B. When C comes closer to B, to the perpendicular BC. What happens to BC? So BC approaches to 0 because C is falling on B. So that the difference between B and C decreases. So C coincides with B. That means BC length approaches to 0. And what happens to AC? AC. So AC becomes AB because C is going to B. This AC, when C falls on B, AC approaches to B. We don't say AC equal to AB. It approaches to AB. Now in that case, what is sine of 0? Sine 0 will be 0 degree. It's perpendicular by hypotenuse. What is perpendicular? Perpendicular is BC. And what is the hypotenuse? Hypotenuse is AC. And what is BC? BC is approaching to 0. 0 upon AC, so sine 0 is 0. So when theta approaches to 0, sine 0 approaches to 0. Now let's take cos of 0. Cos of 0 is base by hypotenuse. What is my base? That is AB. And what is the hypotenuse? Hypotenuse is AC. AB is same, but AC approaches to AB. So AC goes to AB, so the value is 1. So cos 0 is 1. Sin 0, 0, cos 0, 1. Let's see what happens to tan. Tan of 0. Tan is perpendicular by base. Perpendicular is BC. Base is AB. BC approaches to 0. So 0 upon AB. 0 by any number is 0. So tan of 0 is also 0. So we have to remember these values. I'll be helping you to frame a table in which all these values are listed so that we remember these values so that we could apply them as far as sums are concerned. So theta equal to 0. This is done. Now the last is theta equal to 90. Let's move to that. So sine 0, 0, do remember, cos 0, 1, tan 0, 0. Now we'll take the next case when theta is 90. Let's see what happens in that case. So as theta approaches to 90, that means theta is increasing. Theta is going to 90. So how's the diagram? Diagram will be like this. The same figure you had A, B, C. This is theta. Now theta has to increase. When theta has to increase, that means A should come nearer to B. See, when A goes nearer to B, the magnitude of theta increases. This is second figure. A is coming closer to B. Let's go to the third figure. This will be third figure. A, B, theta. So theta increases, theta approaches to 90, so A is approaching to B. And the last figure, I should draw it this way. This is A, this is B, this is C, this is theta. So A is approaching to B. So when theta approaches to 90, theta can't become 90, then such a triangle won't exist. You can't have two right angles in a right triangle. So if it approaches to 90, what happens? In that case, A approaches to B. If A is approaching to B, what happens to AB? A is coming nearer to B. So the distance between A and B is shortened. So AB approaches to 0. And what happens to AC? So AC approaches to BC because A approaches to B. So AC approaches to BC. So we'll list first three T ratios. With the help of those, we could list the remaining three. So what is sine of 90? Sine is perpendicular by hypotenuse. My perpendicular is BC. My hypotenuse is AC. BC. But what is AC? AC is approaching to BC. So this is 1. So sine 90 is 1. What about cos of 90? Let's see. Cos of 90 is cos is base upon hypotenuse. Base is AB. AB upon hypotenuse is AC. AB becomes 0 because A is approaching to B. AB approaches to 0. 0 upon AC, 0 by any number is 0. Then we have tan of 90. Tan is perpendicular upon base. My perpendicular is BC. Upon base, base is AB. Okay. This is BC. Upon AB, AB approaches to 0. This is not defined. We can't divide by 0. We say it's not defined. So three values, three T ratios only we listed, because the remaining three you could do taking help of the reciprocal results. Cosec could be taken from sine, secant from cos, and cot from tan. Now we have derived the T ratios for all 5 specific angles. They are also known as standard angles because in daily life we come across, especially in physics, it has wide application, this trigonometry, in all branches of physics. So we'll frame a table. I will help you how to frame a table and how to retain these values. That is quite important. So I'll be rubbing this. Now what we have derived, what we evaluated, we're going to tabulate it. Now see how we tabulate it. I'll be making the table here because we have to refer to that while doing the sums. So I'll be writing the angles along this column like 0 degrees, then it's 30 degrees, then 45, 60, and 90. These are the angles, 5 angles. So along this side you have T ratios. Let me first take sine of theta. So sine theta will give me cos theta, and sine and cos will give me tan, and those 3 will give the remaining 3. So main thing is to remember the value of sine of theta. This column you have to remember, simply this much you have to remember, rest you manage on spot. So sine 0, remember this is 0, this is 1 upon 2, this is 1 upon square root 2, this is square root 3 upon 2, this is 1. This you have to remember. That sine of 0 is 0, 30 is 1 by 2, 45 is 1 by root 2, 60 is root 3 upon 2, and 90 is 1. Students say, sir, how we remember this if we forget? But you have to remember it, you have to memorize this. 0, 30, 45, 60, 90. There's other way of doing it also. Now, you have prepared the sine column. Now, with the help of sine column, you could prepare the cos column. So, my cos of theta will be, now next column is cos of theta. Now, these sine values, you rewrite backwards. That means this 1 I write here, this root 3 upon 2 I write here, this 1 upon square root I write here, 1 upon 2 I write here, 0 I write here. So retaining sine helped you to prepare cos column. That means sine of 0 is 0 and cos 0 is 1, cos 30 is root 3 by 2 and so on. You could just manage this table. Now make the third column as tan of theta. So tan, we remember tan is sine upon cos. It's a quotient result. So tan will be, tan of 0 will be 0 upon 1. 0 by 1 is 0. 1 by 2 divided by root 3 by 2. If you do the simplification, 2 and 2 will go. This is 1 upon square root 3. 1 by root 2 divided by 1 by root 2. Same number you are dividing, you get 1. When you divide root 3 by 2 with 1 by 2, the denominator cancels. You get square root 3. And 1 by 0, we can't divide by 0. This is not defined. Don't just worry. You won't get a value for tan of 90 in the examples. Means the questions that are asked in the examination. So we have prepared sine, cos, and tan for all 5 values, 0, 30, 45, 60, and 90. Now, just beneath sine, I will write cosec of theta, because cosec could be prepared using sine. Cosec is a reciprocal of sine. And beneath cos, I write secant of theta. And beneath tan, I write cot of theta. Now, how you are going to manage this table? For example, question is asked, what's the value of secant of 60? So, you go to the 60 row, 60. Now, secant is not there, go to cos, because secant is a reciprocal of cos. If secant 60 is asked, so you see what's the value for cos 60. That's 1 by 2, reciprocated. It's 2 upon 1, that is 2. This way you have to work. For example, if you are asked what's the value of cos of 90. So cos column and 90 row, that is 0. What's the value of tan of 60? It's square root 3. Let's take the higher t ratios. For example, what's the value of cosec of 90? So for cosec, I need to go to sine. What's sine 90? It's 1. So cosec would be its reciprocal 1 by 1, that's 1. Okay, what's the value of, for example, take, what's the value of cot of 60 degrees? So for cot, I will go to tan, cot 60, tan 60 will help me. Tan 60 is square root 3. It's square root 3 by 1. So cot 60 will be, it's a reciprocal 1 upon square root 3. So that means you have 60 ratios and 5 angles. That means 6 into 5, 30 values. So this table is going to give you 30 values, and you don't expect a question in which you have all these 60 ratios and all angles are involved. Some of the angles are involved. So what we'll be doing, we'll be making this table and referring to this table whenever a question based on t ratios of specific angles is asked. So I'm not going to rub this table because we're going to refer to this table. Just this table is to be made in the examination so that you refer to it. Now we'll move on to the textual exercise, that's 8.2. exercise 8.2. Okay, this is based on this topic. So let's try to take some of the sums. You are asked to evaluate, like first question is, evaluate sine 60 cos 30, like sine 60 cos 30, this is degrees, plus sine 30 cos 60. Sine 30 cos 60. So the first thing you have to do in your examination when you are working with questions like this, make a table on the right hand side and don't rub it, just make it and refer to it. Now values are to be taken from that and put in this expression. This is my trigonometric expression as we did in the previous video. Sine of 60, my dear friends, is 1 upon 2. Put the value. This is into. Cos of 30 is square root 3 upon 2. Plus sine of 30 is 1 upon 2. Into cos of 60 is 1 upon 2. Okay. We have to cross check if I'm putting the values. Sine 60, see. Sine 60 is root 3 by 2. This happens. Sine 60 is root 3 by 2 and cos 30 was root 3 by 2. Sine 30 is 1 by 2, correct? And cos 60 is also 1 by 2. Now we'll further simplify. Root 3 is square root of 9, which is 3 simply. 3 upon 4 plus 1 upon 4, that would be 4 upon 4, and the value is 1. Right? So for this expression, its value is 1. Now, if you make an observation, my dear friends, here, see, sine 30 value and cos 60 values are same. Because 30 and 60 are complementary angles. 30 and 60, those two angles which are complementary, two angles which sum up to 90, they are known as complementary angles. For them, sine of theta, or I would say sine of x is cos of y, provided x plus y is 90. Sine of one angle x will be cos of y if x and y are complementary. Now see, if I put x as 0, so sine 0 will be cos of 90, because 0 plus 90 is 90. Now sine 45 and cos 45 are same, because 45 and 45, they are complementary angles. Sine 60 value is same as cos 30 value. And sine 90 value is same as cos 0, because 0 and 90 are complementary angles. That's why cosine is co-function of sine, because of two angles being complementary. Now we'll move on to one more sum. This was pretty easy. This is second part of exercise 8.2, question number 1, part 2. You are asked to evaluate the value of 2 tan square 45 plus cos square 30 minus sin square 60. Twice tan square 45, twice tan square 45 plus cos square 30 degrees and minus sin square 60, minus sin square 60. So what do you mean by tan square 45? It means the value of tan 45, square that. There shouldn't be a confusion. If you have tan square theta, this doesn't mean tan theta square of that. No, this is different. Tan square theta simply means whatever value you have for tan of theta, square that. So tan theta whole square, in short, is written as tan square theta. Don't put this square on theta. That is something different. This is different than this. So this will be 2 tan 45 and square of that, not the square of 2. Cos 30 and square that, minus sin 60, square of that. So tan 45, if you observe, that's 1. With passage of time, you will be retaining all these values when you work on questions based on this table. Cos of 30 is root 3 upon 2. Cos of 30 is root 3 upon 2, and square of that, minus sine of 60 is root 3 upon 2 square of that. Now if you observe, these two values could be cancelled. So you simply got 2 into 1, that is 2, because these two are same. So the value for this expression is simply 2. This was second part. Now there are 3 more parts for this sum. Question number 1 concerned. Let me go to a higher part, like question part 3. So we'll take a couple of parts here. Okay. Part 3, question number 1. This is in quotient. Find the value of cos 45. Cos 45 degrees whole upon secant 30 plus cosec 30. Sec 30 means secant 30 plus cosec 30. Okay, this is part 3. Let's go to the table. Take help from the table. Cos 45 is 1 upon square root 2. And go to the denominator. Secant 30. So secant is given by cos. Cos 30 is root 3 by 2. So secant would be its reciprocal 2 upon square root 3 plus cosec 30. Cosec 30. Sin 30 is 1 by 2. Cosec will be its reciprocal 2 by 1. So I have an irrational number in the denominator for which you need to rationalize it. This will be 1 upon square root 2. If you simplify the denominator, 2 could be taken common. I would say this is 1 by root 3 plus 1. If you don't want to take 2 common, doesn't matter. It will still give you the same result. So this is 1 upon square root 2 whole upon 2 into 1 plus root 3 upon square root 3. Now further simplify it. This will be 1 upon square root 2 into square root 3 upon 2 into 1 plus root 3. What I did, I expressed this numerator is as it is. Whatever was in the denominator, you have reciprocated it. Root 3 went to the numerator. 1 plus root 3 and 2 is already in the product. So that would be square root 3 is in the numerator. No need to rationalize. We rationalize an irrational number which is in the denominator. This will be 2 square root 2 into 1 plus square root 3. You have 2 irrational terms in the denominator. This is a binomial. This is a monomial. So we have to rationalize. Make this root 2 as rational, same as 1 plus square root 3. We'll do it 1 by 1. I'll continue this. I'll be rubbing this part. So that means I have square root 3 in the numerator by 2 into square root 2 into 1 plus square root 3. If I multiply square root 2 in the numerator and in the denominator, so that root 2 in the denominator gets rationalized. So I will have root 6 in the numerator. This will be 2 into square root 2 into square root 2 is 2 into 1 plus square root 3. So that means square root 6 whole upon 4. This I would like to express as root 3 plus 1. Because we are going to rationalize it and root 3 value is more than 1 just to avoid the negative sign. So again rationalize at this spot. This will be multiplying numerator by root 3, the conjugate of root 3 plus 1, multiplying with the numerator in the numerator and in the denominator. So what's the next step? Next step will be, okay, I have square root 6 in the numerator, root 3 minus 1. We will simplify it till we rationalize the denominator. This is 4. Here you use the result. You have been doing so since grade 9. A plus B into A minus B. That is A square minus B square. Famous identity. A plus B into A minus B is your A square minus B square. So that means root 3 whole square minus 1 square. A plus B, A minus B, A square minus B square. So this means square root 6 into root 3 minus 1 divided by 4 into square root 3 square is 3, 3 minus 1 is 2. So I can leave it at this spot. So I have now rationalized the denominator. It's 8. Although numerator got irrational. It became irrational. So square root 6 into square root 3 minus 1 upon 8 is the value of this trigonometric expression. That was part 3. I have 2 more parts. I would like to take one part so that we move on to the next sum. Fourth is also there. Fifth is also there. Fifth being a little bit tricky than fourth because you have t ratios, but they are squared. So I'll take the fifth part. We're rubbing this part. Question number 1, part 5. Evaluate 5 cos square 60, 5 cos square 60 degrees, plus 4 secant square 30, plus 4 secant square 30 degrees, minus tan square 45, minus tan square 45. This is divided by sin square 30 plus cos square 30. Sin square 30 plus cos square 30. 5 cos square 60 plus 4 sec square 30 minus tan square 45 on sin square 30 plus cos square 30. So you are asked to find the value of this trigonometric expression. Now 5, what's the value of cos of 60? It's 1 upon 2 square it plus 4 secant square 30. Secant, I have to go to cos. What's cos 30? Root 3 by 2. So secant will be its reciprocal. 2 upon square root 3, square of that, minus tan 45, just it's 1. So 1 square of that, whole upon sin square 30. Sin 30 is 1 by 2, square of that, plus cos 30 is square root 3 upon 2 and square of that. So you have put the values of these specific angles 30, 45 and 60. Now we need to simplify this further. This will give you 1 upon 4. This will give you 4 into 2 square is 4 upon 3 square is 3 minus 1 divided by, this will give you 1 by 4 plus root 3 square will give you 3 upon 4. 2 square is 4. Okay. Can we do any simplification here? No, this is 5 by 4 plus 16 by 3 minus 1. And what about the denominator? If you observe LCM is 4, it's 4 by 4, that's 1. Just check it. 3 plus 1, 4, 4 by 4, 1. No need to write that. So I could take this 1 as 1 by 1. My LCM is 12. So we need to take the LCM. So that means you will multiply this by 3 up and 3 down. So this is multiply 3 up and 3 down. 15 by 12 plus multiply 4 up and 4 down. 64 by 12 minus 12 by 12. So that will give me 15 plus 64 minus 12 upon 12. We have taken the LCM, 15, 64 and 12. So that is 90, 549, 79 minus 12 upon 12. So 9 minus 2 will give me 7. 7 minus 1 will give me 6 upon 12. This is odd, this is even, so you can't simplify it. So 67 by 12. That is the answer for this expression. So that was part 5 of question number 1. So when you are comfortable with this table, you are comfortable with the rest of the sums which are based on these values like 0 to 90. So we'll take up one more sum. This is an MCQ type, and options are given. Out of 4 options, you have to see which option is to be taken. But for that, you have to evaluate it first. Let's move on to the next sum. This is question number 2. This is an MCQ sum. We'll find the value and see which option matches with the correct answer. It says choose the correct option. This is question number 2. 2 tan 30 upon 1 plus tan square 30. First part, 2 tan 30 upon 1 plus tan square 30. Now there are 4 options given, like sin 60, cos 60, tan 60, sin 30. 4 options are given. A is like sin 60, B is cos 60, C is tan 60, and D is sin 30. This is an MCQ worth 1 mark. So you'll evaluate this and see out of these 4 options which is the correct one. So I will take this expression 2. Tan 30 tells me it's 1 upon square root 3 divided by 1 plus tan square 30. That means 1 upon square root 3 whole square. This is nothing but 2 upon square root 3 divided by 1 plus 1 upon 3. Root 3 square is 3. If you further simplify, this is 2 upon square root 3 divided by 3 plus 1, that is 4 upon 3. Okay, now we have to see out of this which is the correct option. So 2 by square root 3, this will be 3 upon 4. Now 2 1s 2, 2 2s 4. So this is 3 upon 2 square root 3. So this is not a value for any of the 3 ratios. So what I do, I will rationalize this. See, 3 I got 2 root 3. I will rationalize root 3 upon root 3. So numerator I got 3 square root 3 upon 2 into root 3 is nothing but 3. 3 goes with 3. You got root 3 upon 2. So root 3 upon 2, if you observe, that is sin 60 as well as cos 30. But cos 30 is not given, so the correct answer is sin 60. Observe, root 3 by 2 is for sin 60. In terms of cos, it's for cos 30, but cos 30 is not an option given. So sin 60 is the correct answer as far as this sum was concerned. One more sum we will take. Second part is 1 minus tan square 45 upon 1 plus tan square 45. Same as we did the first part, 1 minus tan square 45 upon 1 plus tan square 45. So this is second part. You will be putting the values. See, 1 minus tan 45 is 1. So this is 1 upon 1 plus 1. When you square it, this is still 1. This is 0 upon 2, that is 0. Because tan 45 is 1, so this would be 1 minus 1, 0, 0 by 2, that is 0. What are the options given? Options given are tan 90, 1, sin 45, and D is 0. So D is the correct answer. For this, 0 is the answer. That is the option D. There's one sum like sin 2a is 2 sin a. This is third part. Let's try this sum and then we'll move on to question number 3. Sine of 2a, it says it's twice sine of a. For what value of A? A is given 0, 30, 45, 60. A is 0, B is 30, 45, and 60. D is 60 degrees. This is part 3, question number 2. That means sine of 2A is twice sine A. This is a trigonometric equation. This is true for what value of theta? You can do it by hit and trial. If you take the value of 0, if you take the left hand side is sine of 2A. This is sine of 2. A is 0, so this is sine of 0. That is 0. See, sine of 2A, this is the angle. So twice of A, if I take A as 0, so 2 into 0 is 0, sine of 0 is 0. And what about my right hand side? Right hand side is twice sine A. This is twice of sine A is 0. This is 2 sine 0 is 0. That is 0. So it's true. Therefore, the option is 0. Means A. Now, see here you have double angle. This is twice of the angle and this is twice of sine of A. This is sine twice of A. That is twice sine of A. It's true for A equal to 0. Now, I'd like to take one important sum which has been asked a number of times, worth 2 or 3 marks. That is question number 3. It says tan of A plus B, if tan of A plus B is square root of 3, this is question number 3, and tan of A minus B, tan of A minus B is 1 upon square root of 3. You could observe that it's given that A plus B, some conditions are given for the angle. It's less than equal to 90 and greater than equal to 0. And given that A is greater than B, you are asked to find the value of A as well as B. So this is an important sum as far as this exercise is concerned. My dear friends, you have 2 trigonometric equations. Both are in terms of tan. First says tan A plus B is square root 3. Tan A minus B is 1 upon square root 3. A plus B is less than 90 and this 0. That means A, they are in the first quadrant. That means A and B are both acute. It starts with 0 and it's with 90. These are the extreme cases, 0 to 90. But A has to be greater than B. What's the value of A and B? So what we'll do, we'll observe that if it's tan, we go to the tan column. I'll focus on the tan column. Now tan of A plus B is square root 3. I will say that, okay, if tan A plus B is square root of 3, then tan of which angle is square root of 3? That is 60. So tan of A plus B is tan of 60. Because square root 3 is 60 for tan. That means A plus B is 60. This is equation 1. If tan A plus B is tan 60, so A plus B has to be 60. This is equation 1. Let's move on to equation 2. Tan A minus B is 1 upon square root 3. So tan A minus B, in tan column, what's 1 upon square root 3? That is 30. So this is tan of 30. So this is going to give you A minus B is 30. A minus B is 30 degrees. So you have 2 equations. Both of them are linear. They are linear in A and B. Same like you have linear equations in 2 variables in grade 10th also you have done x and y. Same as for A and B. We'll be solving these 2 equations to get the value of A and B. We'll try to complete this sum. So I will continue it here. My A plus B is 60. And my A minus B is 30. You could use any of the methods. Let's use elimination method because coefficients of B are same. If I add, when I add this cancels, I get 2a equal to 60 plus 30, that's 90. So a will be 90 by 2, that's 45. Now put a in one of the equations. My a plus b is 60. My a is 45 plus b is 60. So b will be 60 minus 45. So b is 15. So a is 45, b is 15. So a was greater than b, so that is verified. So if you have a question like this, whatever t ratio is given, like tan was given, so you worked on the tan column. If it's sine and cos, so you will work on that appropriate t ratio. There's an example also listed, this example 8, this in terms of sine and cos, so you will do it accordingly. Now, we have the last sum of this exercise that will bring us to the end of this video. This is true, false, so we'll work on this sum taking help of the table, trigonometric table, T table. You could name this as T table. This is question number 4. You have to state if it's true or false. Sine a plus b is sine a plus sine b. First part. It says sine of a plus b. This is equal to sine a plus sine of b. Is it true? This is not true, my dear friends, because see what he is using. He is using the distributive property of multiplication over addition. For example, you have a into b plus c. You have done this in lower classes as ab plus ac. So a gets multiplied to b as well as c, distributive property of multiplication over addition. It's true for subtraction also. And in this case, he is applying sine. He is multiplying to a, sine multiplying to b. And the sign is plus. This is not possible because this is not product of sin and a plus b. Here you have product of b plus c and a. So a and b plus c, they are, what's the operation in between? That's multiplication. So a is multiplied to the sum of b and c. Here sine is not multiplied to the sum of angles a and b. This is not sin into a plus b. This is sine of a plus b. So a plus b is the angle. So this is one single entity. For example, you have sine of 90 degrees. You could rewrite this as sine of 60 plus 30. So that doesn't mean this is sine of 60 plus sine of 30. See, sine 90 is 1. What is sine 60? Sine 60 is root 3 by 2 and sine 30 is 1 by 2. If you simplify, this will be root 3 plus 1 upon 2, but they are not same. So this is not the multiplication of sine with a plus b. So that way it's false. The next part says the value of sine theta increases as theta increases. As theta increases, sine theta increases. Go to the sine column. As theta increases, what happens to theta? What happens to sine theta? It does increase. So with an increase in theta, sine theta also increases. So this is true. As theta increases, sine theta also increases. The next part says, this is the third part, the value of cos theta increases as theta increases. The value of cos theta increases. Go to the cos column. As theta increases, cos theta decreases. From 1, it goes down to 0. So as theta increases, cos theta decreases. So the option, if you were asked, the value of cos theta increases as theta increases, this is false. Fourth part is sin theta equal to cos theta for all values of theta. Sin theta equal to cos theta for all values of theta. Let's try to observe it. Sin theta value is same as cos theta. It says for all values of theta. Theta is your acute. Just have a look at sin and cos column, make a comparison. Just here only you could see sin theta and cos theta values are same for theta equal to 45. So it's not true for all values of theta. Sin 0 and cos 0, they are different, same as for rest of the angles. So this is not true. It's true for only one value of theta, as for theta is acute. So this is false. Then it says cot A is not defined at A equal to 0. Cot A cot of A is not defined at A equal to 0. What is cot of, this is 0 upon 1 basically, my dear friends. If angle is 0, tan 0 is 0 by 1 and cot will be 1 upon 0, which is not defined. It's true. I repeat, if my angle is A and it's 0, tan 0 is 0 and cot will be its reciprocal, 0 by 1, that's 1 by 0, which is not defined. So it's true. So that brings us to the end of this video. I hope this is going to help you as far your introduction to trigonometry topic is concerned. We'll continuing in my next video. I'll be taking up the T ratios for complementary angles. I think one more video required for that. And at the end we have T identities, trigonometric identities. Many questions are being asked from trigonometric identities. We need I think 2 videos for trigonometric identities because there's a lot of variety. So see you in the next video. Till then, happy learning.